Hey everybody, you see the title. It was originally intended to be 20 years of bad design decisions in open source search, but now I decided to go even beyond search. So a lot of the concepts that I'm going to mention, they apply to a lot of software, storage, databases, file systems, operating systems, browsers, and so on. So there's this weird thing that we see in software all the time. When the consumer comes in, they want features. The consumer can be anyone, can be another developer. Then we have the maintainers of open source projects who would say, okay, we're going to add that. And we're going to do that by stacking another layer of abstraction on top of it, which kind of almost always results in collecting more legacy. But then the third part of the puzzle that we keep forgetting about is that the software is changing, but the hardware is changing as well. And the direction in which hardware is changing, or at least has been changing in the last 20 years, is practically orthogonal to almost everything we do in software. The newer devices with a lot more transistors are a lot slower. So you type in a button on your keyboard on a $3,000 machine from last year, and it takes more time for it to render on the screen than it took 40 years ago. Why is that? Search is one of those places where we kind of use search in every application. We use it in different forms, but it's one of those things that is, even though it's like ubiquitous, it's one of those features that's never present in the standard library of any programming language or any environment. The first root cause is about virtualization. The more obvious thing to benchmark, however, than the memory consumption is like how well you utilize recent assembly features. Comparing assembly to Python or like other high-level languages would produce gap that even for a single core execution would be in multiple orders of magnitude. And I'm not even talking about like concurrency and parallelism. Another problem that happens a lot in modern machines is I/O. And in most cases, when we think about I/O, it's either storage or networking. In fewer cases, it's like the broader memory. If you start using those libraries directly in the C layer or forking them and trying to patch them, you realize that the interface of those libraries kind of forbids you from using them properly in a synchronous manner. The problem that it incurs is that when we have a process that needs to do I/O, in between we are wasting hundreds of thousands of CPU cycles that are spent just waiting for data to arrive from somewhere, from disk or from network. The last but not the least, still huge, is how we deal with strings. So this is actually going back further than 20 years. A lot of the string processing that's happening in C is influenced by the language B. And back then, the registers in the modern CPUs were really scarce. So we used just like one pointer to describe a string. And then everything that went into libc had string interfaces that didn't pass the string length as an argument. So within every single function call, we had to compute string length and only then start processing. There are a few projects that kind of help avoid all of this legacy. Here are the ones that I love the most. So to make virtualization cheaper for all of us as a community, I strongly encourage you to look into WebAssembly. There is a company and a project that takes it further. So if you want a hardware-friendly programming language built on familiar compilers, there's a big effort by Chris Lutner and his team at Modular designing the modular programming language. There are new system languages if you don't want the legacy of LLVM and MLIR, like Zig, which comes pre-encapsulated with its own compiler toolchain. But then there is also systems like SPDK and DPTK for kernel bypass. And the probably simplest approach, the one that we follow, designing custom kernels and operations for the most data-intensive workloads. But probably most importantly of all efforts is this one, which brings all of it together into one single open source search engine. It's still a work in progress, but at the time of writing, it was already used by some of the projects at Google. It was used by open source databases like ClickHouse, and now close to a dozen other database brands, some of which are open source. This is probably like one of the world's most deployed search engines. It also runs on mobile devices. So I'll be more than happy to see all of you participating in this effort. And ping me if you have any questions. Thank you.